We continue looking through the PDF document presented by the Siemens STEP or T, that's Siemens Technical Education Program, which can be found by eandm.com. We look at electric charges, the neutral state of an atom. Elements are often identified by the number of electrons in orbit around the nucleus of the atom making up the element, and by the number of protons in the nucleus. A hydrogen atom, for example, has only one electron and one proton. An aluminum atom, which you see here, has 13 electrons and 13 protons. An atom with an equal number of electrons and protons is said to be electrically neutral. It is neutral because the positive and the negative charges cancel each other out exactly. Positive and negative charges. Electrons in the outer band of an atom are easily displaced by application of some external force. Electrons which are forced out of their orbit can result in a lack of electrons where they leave and an excess of electrons where they come to rest. The lack of electrons is called a positive charge because there is more protons than electrons. Remember, an electron there were equal number of electrons and protons, and then an electron left. When an electron leaves the atom, then you have one proton that is not neutralized because its electron has gone. An electron that had neutralized it had gone. So therefore, you have an extra positive charge left behind, which is a proton. The excess of electrons has a negative charge. So whichever atom the electron went to, they were neutral and just got an extra electron, so they are negatively charged. That atom is now negatively charged. A positive or negative charge is caused by an absence or excess of electrons. The number of protons remains constant. So remember now, the protons and neutrons are tightly packed together. It's not easy to move a proton out of the nucleus. Neutral charge, you have 3 positive and 3 negative. Negative charge, you have 3 positive and 5 negative. So you have 3 of the negatives cancelled out by a positive and 2 extra charges. Here you have a positive charge. You have 3 positive and only 1 negative. One of these positive charges is cancelled out by a negative, so it leaves 2 extra positive charges. Attraction and repulsion of electric charges. The old saying opposite attract is true when dealing with electric charges. Charged bodies have an invisible electric field around them. When two like charged bodies are brought together, their electric field will work to repel them. When two unlike charged bodies are brought together, their electric field will attract them. So what that means, if you bring two like charges, that means two positive charges or two negative charges, they will repel. Two objects, each of them positively charged, they will repel each other. Objects, each of them negatively charged, they will repel each other. But if one is positively charged and the other negatively charged, they will attract each other. Now sometimes you see this, for example, when you are wiping a window with a cloth, the dust tends to stick to the window and are hard to remove because the dust and the window become oppositely charged to each other. Now, the electric field around a charged body is represented by invisible lines of force. The invisible lines of force represents an invisible electric field that causes the attraction and repulsion. So you can see the illustration here. The one on the left is positive, the one on the right here is negative. You can see here, we're dealing with this part, unlike charges attract. This one on the left positive, this one on the right is negative, so they attract each other. Over here, like charges repel. Both of them are positive, so they repel each other. So lines of force are shown leaving a body with a positive charge and entering a body with a negative charge. So that's a convention, right? Now, Coulomb's law. During the 18th century, a French scientist, Charles A. Coulomb, studied fields of force that surround charged bodies. Coulomb discovered that charged bodies attract or repel each other with a force that is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Today we call this Coulomb's law of charges. Simply put, the force of attraction or repulsion depends on the strength of the charged bodies and the distance between them. So the closer you place them, the stronger the attraction or repulsion will be. Also, of course, the intensity of the charge will also determine the repulsion or attraction between those two bodies. The next thing we're going to be looking at is current, but we will wait until the next video to do that. So I will see you in the next video, is when we talk about current.